In recent years, the war in Ukraine has become a real laboratory of military technology. The world watches in real time the rise of a new war age, where long-range autonomous drones have become protagonists on the battlefield. In this video, we will explain in detail how these systems are used by Ukraine, their technical capabilities, and the strategic impact of this silent revolution. The highlight of this new arsenal is the Gogol-M drone, a unmanned aerial vehicle 100% autonomous that has attracted the attention of military experts worldwide. Gogol-M does not depend on a remote operator to conduct its mission. Once programmed, it calculates the route, avoids obstacles, changes the trajectory as needed, and performs the independent attack or recognition mission. But before we talk specifically about Gogol-M, it is important to understand the greatest context of this transformation. Since 2022, Ukraine has invested strongly in the integration of autonomous technologies into its defense systems in response to the numerical superiority of the Russian forces. The country quickly realized that, to balance this disparity, it would need to bet on artificial intelligence, automation, and long-range systems capable of performing missions without exposing their soldiers to direct risk. The use of drones in war is not new, but the difference is now at the level of autonomy. Previously, most VANT operations required human operators, which remotely controlled the flight and the execution of the mission, being subject to human failures, electronic interference, and range limitations. With autonomous drones, this scenario has changed radically. Ukrainian drones are able to fly hundreds of kilometers, deeply entering the enemy territory without continuous communication with command bases, which makes it difficult to detect and neutralize Russian electronic war systems. In addition, the use of sophisticated algorithms allows them to adapt their route as the threats arise, becoming unpredictable and lethal. A recent example occurred with a series of attacks on Russian logistics deposits, located over 600 kilometers from the Ukrainian border. The images that circulated in the press showed precise explosions, the result of the ability of these drones to identify targets and correct their routes independently, even in highly contested environments. In this scenario, Gogol-M stands out as the maximum exponent of this doctrine of war. Developed with a focus on long-range operations, this drone represents the apex of the latest in autonomous navigation technology and artificial intelligence applied to combat. But what does the autonomy of these drones work anyway? The secret is in the combination of advanced sensors such as multispectral cameras, synthetic opening radars, and highly protected global positioning systems against interference. Integrated with trained neural networks to recognize patterns, obstacles, and threats, these drones process in real-time information to adjust their trajectory and decide the best way to achieve the goal. Ukraine has also taken advantage of the flexibility of these systems to perform various missions, from attack on strategic targets, tactical recognition in hard-to-reach areas to sabotage missions in Russian critical infrastructure. All this without endangering the lives of its pilots or operators. Still, in this video, we will detail Gogol-M's technical specifications, its main missions already performed, and discuss how artificial intelligence is shaping the future of military conflicts. In addition, we will analyze the strategic implications of this advance to the balance of power between Ukraine and Russia. But first, it is essential to know in depth Gogol-M, the drone that is rewriting the rules of modern war and making Ukraine an emerging power in the use of autonomous combat systems. Gogol-M is now considered one of the most sophisticated drones in operation in Ukraine. Its name refers to the Ukrainian-Russian writer Nikolai Gogol, but ironically, it also represents a break with the Soviet past. It is now a symbol of Ukraine's technological and military independence. This drone is a 100% autonomous VANT, designed to perform long-distance missions without human intervention after takeoff. Its main feature is the ability to navigate hundreds of kilometers through hostile territories, performing precision attacks or recognition missions, all autonomously. Gogol-M has an average wingspan, suitable to maintain a discrete profile and minimize its detection by enemy radars. It is equipped with a silent internal combustion engine that balances energy efficiency and low noise, increasing its chances of success in stealth missions. Its fuselage is built with composite materials that reduce radar signature, making it difficult to track. In terms of sensors, Gogol-M has high-definition optical systems, infrared cameras, and multispectral sensors, which allow you to identify targets even under low visibility conditions, such as at night or in the midst of smoke and dust. Its synthetic opening radar allows you to map the terrain and detect long-distance obstacles, even without direct eye contact. But what really differentiates Gogol-M from other drones is its shipped artificial intelligence system. AI, based on machine learning algorithms, allows the drone to process data collected by real-time sensors and make decisions independently. Avoid air defense zones, recalculate routes against obstacles or new threats, and even abort missions when conditions are unfavorable. In addition, it has a safe and highly encrypted communication system that allows you to send mission data to Ukrainian command centers, but without depending on this connection to operate. This is fundamental as it prevents the drone from being neutralized by Russian electronic interference, a very common tactic in this conflict. Another important point, Gogol-M can be armed with different types of useful loads, depending on the mission, from high-precision explosives, capable of destroying strategic targets such as ammunition deposits or logistics centers, to electronic war equipment used to block or sabotage enemy communications. This makes it a versatile and adaptable system to the multiple challenges of modern war. Gogol-M's first images in action began to circulate in mid-2023, when deep operations were reported in Russian territory, reaching military and logistics facilities more than 700 kilometers from the front line. Military analysts have pointed out that Ukraine has, with these attacks, done the Russian supply lines and creating a devastating psychological effect. The feeling that there is no safe place even in the interior of Russia. In addition to the direct impact, the use of Gogol-M has had a ripple effect. Russia had to reposition air defense systems more into its territory, weakening protection in the areas of occupation. This has opened new gaps for the Ukrainian forces to explore on other fronts. Another relevant aspect is the low relative cost of these systems. While cruise missiles or man bombings require very high investments and high human risk, Gogol-M represents a cheaper, safe alternative and potential to cause similar or even superior damage, depending on the mission. No wonder, defense experts are calling this model the future of air war. Its ability to operate without direct human intervention, adaptive intelligence, and weaponry flexibility make Gogol-M a watershed in the current military scene. Behind this advance, there is also a technological development ecosystem that Ukraine has been consolidating in recent years, with the support of international partners and specialized local intelligence, sensors, and autonomous navigation systems. The result is a product that not only meets the immediate needs of the conflict, but also serves as a test platform for the future of military operations on a global scale. Artificial intelligence is the key that transforms drones like Gogol-M into truly autonomous and efficient machines. The use of AI allows these unmanned air vehicles to do much more than simply following pre-programmed routes. They can analyze the environment, learn from combat situations, and adapt their strategies in real time. In the Ukraine war, this capacity has been a decisive differential. The unprecedented mission with autonomous drones equipped with AI represents a technological advance that few countries have been able to reach so far. The ability of these drones to act without continuous human supervision reduces response time and minimizes error or interference risks. A fundamental point of the operation is the use of AI for automatic recognition and target selection. Unlike traditional drones, which need an operator to identify and validate the target, AI drones can, based on databases and machine learning, identify patterns, military structures, vehicles, and even enemy movements, making decisions to prioritize or abort attacks according to the field situation. This operational autonomy paves the way for a concept called scalable mission. Dozens or even hundreds drones can be launched simultaneously, coordinating their actions with each other, communicating safely and attacking multiple targets on different fronts, almost like a swarm. This capacity makes the battlefield a highly dynamic and unpredictable environment for the enemy. Another important advance is the integration of embarked electronic war systems. Some Gogol-M drones can issue signs to confuse radars, block communications, and even create false signatures, increasing their survival and effectiveness in missions. AI combination with these electronic technologies creates a scenario in which traditional defense becomes less effective. In the strategic level, Ukraine has been using these autonomous drones to carry out precision attacks that reach vital points of Russian logistics. Fuel deposits, communication lines, command centers, and reinforcement units. These attacks undermine the enemy's ability to reorganize, expanding pressure on invasive forces. For Russia, the presence of these autonomous drones represents a new and complex challenge. Traditional anti-aircraft defenses, aimed at larger and less mobile targets, have difficulty reacting to these low-flying systems, change trajectories quickly, and do not depend on constant communication. This requires tactical changes and increased operating costs to try to counteract the threat. More than a simple technological innovation, the use of autonomous drones with AI in Ukraine signals a profound change in modern war. Automation and artificial intelligence are expanding the capabilities of armies, creating a battlefield where information, speed, and adaptability are as decisive as firepower. This transformation also puts in the center of the debate ethical and strategic questions about the use of autonomous machines to decide on life and death in armed conflicts. The Ukrainian mission is a demonstration of the potential and risks of this technology, which promises to completely reshape war in the near future. Finally, drones like Gogolem represent convergence between cutting-edge technology and immediate strategic needs, showing how Ukraine is at the forefront of this war revolution. The future of conflicts increasingly goes through intelligent and autonomous systems capable of operating away from human reach, forever changing the dynamics of combat.